Damn.
Good morning, everybody. Welcome back to the Bread and Bird YouTube channel. Today is a good day, and I'm very excited because the K24A2 has made its way out into the light to get some work done. I know there's a lot of people that are on this channel specifically for this build. What I've learned being on YouTube for a while is that people are here to get their information, and I learned that on the subframe video I did for the car that this engine's going into. People just want to see how it's done and then be able to avoid making mistakes themselves. That's why I'm here. That's what I want this channel to be. So if you've watched this channel and you see this engine before, you notice that some things have been undone. Things like the wiring that I did. I have a video that's getting a lot of hits on this. To those people, I'm sorry. This is not conducive to what I'm trying to do with this engine. So we'll cover why in the wiring section, so stay tuned for that. But right now, we're going to take this engine and we're going to try to push it over 600 front wheel horsepower with as many Honda parts as possible. And these next few videos are going to be broken down into sections on this engine on how I plan to do that. This is not the Bible on how to do it. I can't guarantee that it's going to work, although the research I've done has shown that it should at least come very close to that goal. So what we're going to do today is get started on that video series, and then from here there will be no more long-winded intros like this, and we'll get right to work. So today's video starts with these parts. Now what I'm going to do is just show them to you now, and then I will explain them in detail when I go to put them on the engine. This is a K20A2 oil pump and VTC actuator, then the proper chain and chain guide and windage tray to fit those components on that engine. This is a K20 Z3 06 to 11 SI oil pan. This is an experiment. I'm not quite sure if this is going to work, but the only way to know is to try it for sure. There's a reason, and I'll explain that as well. This here is a Low Dollar Motorsports combo temp and pressure sensor. That is going to be for our oil side. And again, I'll explain that when we put it on the engine. But today's goal is to get all of this stuff on the engine, so let's get started. Now, in order to get these parts on the engine, we obviously have to get the old parts off. So it's going to start with getting the valve cover, crank pulley timing cover, and the oil pan off of this engine. Okay, so that was pretty quick and easy. Step one is complete. Oil pan, timing cover, and valve cover are off. Something to note here, the bottom two bolts you may have seen me mark in the timing cover, the bottom two most ends are actually dowel bolts. So be sure to make sure those go back in the right spot. It looks like they won't seat fully into another hole, but definitely be sure those go back in the bottom two bolts on your bottom two holes on your timing cover. So as you can see here, this oil pump has a massive counterbalance shaft assembly on it. Now they say that these pumps cavitate. I'm not sure if it's exactly because the counterbalance assembly displaces so much oil away from the pickup here, or if it's got something to do with the pump itself. However, what I know is that over 8,000 RPMs, these pumps become pretty unreliable. So that is why we are swapping out to the more reliable K20A2 pump. These do not have the counterbalance shaft assembly. The other thing is that balance assembly not being down in your oil definitely means that there will be more capacity. So if you're going to swap out that pump, be sure that you know you're probably going to have to add more oil, and that is an experiment we are going to do with these two pans. So with all that being said, step two is going to be to pull off the timing chain, oil pump chain, and oil pump. Now, a very important step to taking your timing chain off is that you need to put the engine at TDC. So what we're going to do now is just go ahead and put our crank pulley bolt back, and then we're just going to rotate the engine by hand until all the marks line up. And I'll show you those marks after I do it. Okay, so these are the marks you need to line up, and these two aren't exactly perfect, but you can see there, those two marks on the pulleys are lined up. So down in there you can see that there's a little yellow mark on the oil pump chain drive, and then there's an arrow on the block right below the light flare there. Those two need to line up as well. Those two can actually line up with those two 180 out. So make sure that those are lined up and these are lined up. And then you're good to start taking your chains off. So let's pop the chains off and the pump off. So in order to pop this chain off properly, the first thing to do is to pull off your timing tensioner, just these two 10s here. And then once that's off, there's two 12s up here. There's this tall one for the head cover stud, and then there's also a regular 12 head bolt right there. Once those are off, the chain should be pretty slack and you can walk it off of your pulleys. Now the pulleys may flop, and that's okay because they're only going to flop to where the valves are closed. So if they flop shut, just leave them there for now, and then we'll handle that later. Now, something I forgot to note when I was saying take the chain off, this chain will not actually come off with the pump on. So basically what we'll do is we'll take the pump loose and then roll it, and then it'll pop out of its own chain. So this one won't come off easily. Don't force it because you don't want to damage this, even though we're not using the pump or this chain anymore. Once we get that off, then we'll be able to take the chain off. Okay, so I got the oil pump, timing chain, all that stuff off. We are basically as far torn down aside from the VTC actuator as we need to be right now. So what the deal moving forward is we need to prepare the new oil pump to go on. But first, look at how much space that thing takes up in the oil pan. I mean, we could potentially be gaining over a quart of space back in this pan. And then this pan here, again, we'll do that experiment when the time comes, but this one should be bigger than that one. So do the math. But next thing, we have to remove this flange from this pump, this whole thing. So what we're going to do is we're going to test fit it on the engine and take a look at how it fits, and then try to take off as little as possible. So this might be a little challenging to do one-handed, but you can see that dowel pin goes right there. That dowel pin goes right there, which is actually the main feed. And then we're being blocked in this whole area by this piece of extruded aluminum, which I'm assuming was put there to keep this pump from being put on this engine by accident. So what I'm going to do is I'm going to mark out on this pump where this needs cut, and then I'm just going to cut it out real quick. Honestly, shouldn't be too hard. Okay, so as you can see, the material's been removed. You do have to grind quite a lot of that bolt boss off of it to clear that area just to the right of that left bolt. You just got to kind of keep going and going and going. But I already test fit this thing and it fits. So now we're going to reinstall it and put the oil pump chain and get new guides on. The new chain, and then there's the guide in here. You can reuse the old bolts. These two bolts right here, these 14s, you will not reuse those. And you will reuse these two 12s. So I'll pull those out of there. We'll put the new chain and the new guide on. Okay, so pretty plain to see that the K20A2 oil pump is on. We reused the old 12mm bolts and the old tensioner and its bolts. We used a new chain, a new guide, reused the old guide bolts. We got our new 10mm in there. So yeah, it's on there, looks good. Everything's nice and tight, and it's good to go. So now that you've got this pump on, there's an extremely important step that comes with deleting the balance shafts, and that is this right here. This is an oil restrictor. And what we need to do is pull that guy out of there, and then there's threads behind it that will allow us to plug this hole. We don't need to plug these two. These were just the mounting holes. Those are fine. But we do need to pull this and plug it. So what we're going to do now is yank that thing out of there and then figure out what threads those are and plug that hole. So these restrictors can be kind of a pain to get out. The easiest way to do it, I've found, is to ram a self-tapper into it and then just use that to pull it out. So just grab a hold of the head of the screw and just use it to pop the restrictor out. That's all it is. It's just a little, basically, orifice that restricts oil flow to the balance shafts, and it's held in place by the balance shaft assembly itself. So how I did this was I took an M8 by 125 bolt or 12mm headed bolt, put blue Loctite and a crush washer on it, and then put it into the hole left behind by the orifice. It comes pre-threaded from the factory, so it's easy to install this. Once it's in there, I just torqued it down until the crush washer basically took. You can kind of feel it give, and then just go a little bit further and you're good. So this sums up the oil pump side of things. As you can see, we have our bolt, chain, guides, and our pump on. So now it's time to move on to the VTC. Alright, so we got our VTC actuator installed, and the way they come out of the box is in the unlocked position. So what you need to do is lock it, so slide it all the way forward and you'll feel it pop into place. That's locked, and that's how you need to torque this thing and install the timing chain. So here you can see on the timing chain there's these two oddball links that are darker than the rest, and their intended purpose is to straddle a dot on the intake camshaft sprocket and on the exhaust cam sprocket here. Then down here on the crank you can see there's one tooth with a dot on it and one darker link, and that link is supposed to go on that tooth itself. And what these do is just help to make sure that the engine is in fact in time. Okay, so our timing chain is back on. These bolts still need torqued, and we'll get to that. This bolt gets torqued to 83 foot-pounds, but as you can see, it's on and the tensioner's on. Now, it's tough to see, but these marks down here are perfectly lined up, but these two up here are trailing just a tad, which I think is a little bit of an indication of some chain stretch, but it's not too bad. It may actually get eaten up when I pull the tensioner pin, so let's pull it. And it was in a pretty neutral state already, so actually all in all pretty good shape. Everything in here is good to go. We just need to torque these down. Now what we can do is get the side cover back on and sealed up, and then we'll put the oil pan on and we'll do that experiment. Okay, so the timing cover is ready to go back on. I got the surfaces nice and clean. Got it, put some gasket on it with just some right stuff from Advanced Auto. There were some spots here, and here that don't actually seal anything that they had RTV on, so I just went ahead and put some there as well. May have had something to do with the two surfaces touching, I'm not sure. I put a little bit around this gasket because I don't have that gasket either, so I just put a nice thin layer on that. And now the engine's mounting surfaces, or I guess mating surfaces, are nice and clean. So I think we're ready to slap that thing back on here. So let's do it. So I went through, tightened down all the bolts and double checked them. This is something that wasn't in the video to start with. I put this on in an older video, but this is the CRV side mounting bracket. I was gonna cover this in a different video when I did the mounts, but it needs to be on here right now to help this gasket set. So definitely wanna make sure that's put back on. Don't let it sit without that, so the gasket won't seat properly. So you can see I put the dowel bolts back where I had marked them that they came from. Otherwise, all the other bolts are the same with the exception of this 14. So that's it for the timing side of things and the oil pump install. So now what we can do is flip this thing over and put the K20A2 windage tray on it, and then do a quick test fit of the K20Z3 oil pan. Now I've got the windage tray set, and something I was a little concerned about was whether or not I was going to have to drill a hole for this bolt head. Actually, the bolt head is not touching. It's very, very close. It's closer than you'd think it would be. I do know that the K20A3 for the base RSX and the K20A2 that came with this oil pump had a plug here, but it was a smaller profile bolt than that. I believe it was maybe even a 10mm head with a like M8 shank on it. But anyway, this is all good. You don't have to drill a hole here, but again, I want to stress, make sure you have that bolt in there. I put blue Loctite and a crush washer on that thing and probably put a little too much torque to it. You don't want that falling out, and you definitely want to make sure it's there. So again, plug that hole. However you do it, make sure it's plugged and it's seated in there well. So anyway, we're going to bolt this down. You can use the original bolts for the other windage trays on here. So we'll bolt this down, and then we're going to test fit that oil pan. Okay, so the gasket surface is reasonably clean, definitely clean enough for an oil pan to go on. Now, here is the moment of truth. This oil pan over here for this K20 Z3, I've never heard of anyone swapping one of these, which probably means it doesn't actually work, but things look promising for it to go on right now, but it is definitely different than this pan. So what we're going to do is we're going to lay it on here. I can't put RTV and seal it yet because I still have to have an oil return for my turbo welded in back here somewhere. So regardless, we're not going to be able to finish this today, but we can at least test fit it. So I'm going to leave these studs in here for now, but I'll probably end up taking them out and replacing them with bolts because that pan has alignment dowels that go here and here. So anyway, this again is just a test fit. I'm going to share this just to document my successes and or failures with this thing. So let's see if we can put this giant beast on here and see if it sets down. And if it does, we'll do our little experiment. So at first glance, looking at this thing, every bolt hole lines up. They're going to be tough for you to see, but all the bolt holes line up. However, the reason it won't seat, one, because this dowel hole was, oh, there we go, that dowel hole right there was exposed to the elements. You can see where it's trying to scrape it. The other one, I'm not sure, it almost just seems like the dowel is too big. I don't know if you can see that or not. But that dowel hole, I'm sorry, the dowel seems like it's too big. However, this is an aftermarket oil pan, so I guess things like this are to be expected. But anyway, I'm going to try to see if I can get it to sit down on there, but definitely if I was to take those dowels out, it would for sure work. But I would rather leave them because it'll obviously keep things nice and lined up. And then if this works, what I'll do is I will take the engine off the stand and just see if it mates up to the bell housing for the CRV transmission, because we're starting to toss a lot of stuff together here, right? We have a TSX engine, Civic SI oil pan, and then we're going to put a CRV all-wheel drive transmission on it. So there's a lot of things that are kind of trying to have to come together here. I'm assuming it's all the same, but we definitely need to double check because it would suck to get this thing welded, get it ready to go, and then have it not actually work out. So see if we can get those dowels in there. Okay, so kind of sucks I had to take the dowels out completely, but that pan seats on this block and all the bolt holes line up. I just have 2 bolts in it right now because I forgot to order the correct bolts, but hindsight, kind of glad I didn't, because if this hadn't worked, I'd have 80 bucks in bolts that just sitting. So we're going to take this pan and sit it side by side with exactly the same pan as this, which is already cleaned up. Okay, so this test is the new oil pan with the balance shafts in it. I know this looks pretty rough, but science. So with the balance shafts, I was able to put 5 quarts in that pan before it started to overfill the backside in this pan's orientation that it will be in the vehicle. So now what I'm going to do is pull the balance shaft assembly out and then fill it up again to see how much more it takes before it overfills. Alright, so the balance shafts are out now, and I was able to pour in 2 more quarts. So this is now a 7-quart oil pan with no balance shafts in it. So we'll take out a 1/2 quart for the other pump that's in there. So we'll say this is a 6.5 quart oil pan. So now what we're going to do is see how much that one holds. Alright, so this is the original pan and original pump. So you can see here the balance shafts are in there and it's about to overflow. And it's tough to see because of all the oil residue in there, but I was able to put 5 quarts in this thing. So I've been filling this up to 4 quarts, dumped it in there, filled it up again to 4, got another one in. So that's 5. So now I'll take the pump and balance shafts out and see how much more it takes. So with the balance shafts out, it took about 1 1/10 more quarts.
So this is a 6.1 quart oil pan compared to this guy's 7. Just the geometry of this pan makes it much larger. So it's definitely the one I want to go with. So now I just got to clean it out and put it back on the engine, get it ready to be welded later on. Something else to note about this oil pan is the built-in stiffener to the transmission that's on it, but we'll cover that in the drivetrain video. It makes this about $300 more cost effective than that one, should you not have the stiffener that goes to that steel pan. So if you don't have that, you got the engine from a junkyard without it, definitely make sure that you tune in for the drivetrain videos, because I could save you a couple $100 with this plan. Okay, so one other thing worth noting, something I'm going to change on this engine. This is your oil pressure switch. It's a Denso part, and it's 1/8 BSPT, which is British Standard Pipe Thread. That'll be important here in a second. I'm not just saying that. This thing is what turns off your oil lamp on your combi meter, and it actually grounds or ungrounds and turns off that lamp at like 4¼ PSI. People say they're 15, 11, whatever. This is actually 4¼ So obviously that is not good to have in a racing application. On top of that, it doesn't tell you pressure, it's just a switch. So I've already loosened it, so I'm going to go ahead and pull it out with my hand. This is a combination temperature and pressure sensor from Low Dollar Motorsports. A lot of people use these guys' parts, and that is because they are awesome. So this thing here, it has a range of, I think it's 0 to 500 degrees and 0 to 300 PSI. I think these are used a lot for torque converter pressure and temperature. So this thing is 1/8 NPT, National Pipe Thread. So basically, it is not, there we go, it is not exactly the same thread as the block. Now, that's not a huge deal. NPT and BSPT are very similar. You can get an adapter for this, but since this is a temperature sensor, I want it as in and as close to that oil as possible. So putting it clear out here after putting an adapter on it is not exactly ideal. So the thing is, normally, and this does bother me, putting two unique threads together is not ideal, obviously, but you hear about people putting 1/8 NPT into BSPT all the time and not having leaks. So basically what I'm going to do is just put some RTV on this thing and put it in there and just get it nice and snug. No need to kill it. And what this will do is allow me to see pressure and temperature in one sensor. So that will be really nice to have. And the other thing is, I'm not using my factory combi meter anymore, so I don't need that light to be turned off. All right, so you can see that thing's in there pretty far. About 1/3 of the threads are in. It's nice and snug, and I'm confident it won't leak. I think we should be just fine. What's nice about that sensor is the computer that I'm hooking it up to has provisions for warnings and protections to be put into it. So if this engine goes into some oil over temp, or even worse, no oil pressure situation, the computer can actually be programmed to kill the engine, shut the fuel off and shut it down to protect it, which is really nice, because that other switch was just going to let you go. So as soon as that lamp comes on, it's toast. This, not the same situation. I can program it to, hey, at this RPM, shut the engine down if the oil pressure is below this pressure. So really, really nice stuff that I can do with that. That's big. I've got more of those. They're expensive, but they're definitely worth it, especially considering this is a stock engine that I'm going to push beyond its limit, way past its design. So anything I can do to help protect it and keep it healthy is necessary. So okay, that about sums it up for this video. In summary, we have a K20A2 VTC actuator, and then a K20A2 oil pump and the related components from a K20A2 to put it in, chain guide, chain. And then we have a K20 Z3 oil pan with a higher capacity. And then we also have the Low Dollar Motorsports combo temp and pressure sensor for oil. So this is a pretty good looking engine. I don't know of anybody else who's put an oil pan like that on one of these, but I think it could be extremely beneficial considering the extra capacity and the integrated stiffener to the transmission. So there's going to be more stuff like that coming, so stay tuned. But that is the end of episode 1